Just about every direction one goes in West Texas these days, they witness drought.
Damaging to the fields and to the pocketbook.
Rainfall a paltry quarter of an inch.
Pastures are fast drying out.
Farmers are waiting on the right conditions to see if they'll have cotton to sell.
Temperatures well in excess of 100 degrees.
The Lone Star State, as far as you can see, is in bad condition.
A lot less wind and a lot more rain would make most farmers happy.
Water is life, our most precious resource. A resource many take for granted. When in short supply, however, all life is affected. In the semi-arid climate of West Texas, water is crucial to its farmers, ranchers, industry, and to its citizens, especially in times of drought. Fortunately, the impact of drought on West Texans has been lessened due to a regional water management plan implemented by the Colorado River Municipal Water District and its former manager, Owen Ivey.
The system that the district owns and operates is one of the most unique systems in the United States. We have 3 reservoirs on the Colorado River of Texas, but those 3 reservoirs are the main source supplies of a large area of Texas, about 450,000 people. From Abilene on the east through Odessa and out to Monahans on the west, north to Snyder, southeast to San Angelo. We operate 22 pump stations, about 600 miles of cross-country transmission lines.
Since 1971, the Water District has utilized cloud seeding in an attempt to augment the West Texas water supply. Results indicate warm season rainfall has been increased up to 30%.
We feel like it's has been positive, particularly from the standpoint of agricultural development. Over the years, of 22 or 23 years of history, we feel like we have been productive, and our board has been encouraged every year to continue it, and I think they will for years to come.
Despite positive results from this long-term program, cloud seeding for rain enhancement has not yet been proven scientifically. Only a systematic program of research can resolve this issue. The state of Texas, through its Natural Resources Conservation Commission, is leading this research effort with funding from the United States Congress under the project name TexARC.
The TexARC project is the Texas experiment in augmenting rainfall through cloud seeding. It is an experimental program designed to develop and refine a technology for enhancing rainfall through cloud seeding in semi-arid West Texas. If we can demonstrate that cloud seeding technology is able to increase the amount of fresh water from convective clouds in the warm season, then obviously that's going to have an impact upon water usage in West Texas, as well as our ability to develop new freshwater supplies. We have been involved in researching the effect of seeding of clouds in Texas long enough to know we are really onto something that has great potential to help Texas get additional fresh water. Unfortunately, at this point in time, there are very substantial reductions occurring in the federal budget that support research, such as the TexARC project, and we're battling like many other people to ensure that this program does have a future.
One of the strongest supporters of cloud seeding research in West Texas has been East Texas Congressman Jim Chapman.
When you move to West Texas, my colleagues and my friends out here have almost a semi-arid condition, but you've got some of the best farmland in the world out here, and if we can get water on that farmland, we know we have the technology, the know-how, the willpower to produce some of the best crops in the world. What we need is water. Atmospheric modification holds the promise of being able to utilize our natural resources, our land, our talents, our people, to create that kind of benefit, and so that's why I think this research is critical. Clearly, there's government spending that ought to be eliminated. Clearly, there are kinds of spending, though, that are tremendously important and work to benefit the whole country. This is that kind of research. We ought to support it, and folks ought to know that the benefits that this can create is something that they ought to encourage their elected representatives to support. It's important not just for West Texas. It's important, I think, for ag production in semi-arid regions worldwide.
Providing scientific leadership to the Texark project are Doctors William L. Woodley and Daniel Rosenfeld.
I was born with the interest. 4 years old, I used to sit in front of windows and watch every raindrop fall into a puddle in Southern California.
I've been a weather nut since I remember myself as a very small kid. Whenever it rained, I ran outside just looking at the rain. My mother didn't like it so much, but she couldn't help it.
My career led naturally into meteorology, and I have a strong scientific interest in knowing how things work and why they work.
Later on in university, I studied it more seriously, and today I'm trying to do something about it in our research.
It's exciting work, and I'm happy and privileged to be working here in West Texas with the people of West Texas.
The most important thing is still the intuition, knowing which questions to ask, what to do with all the data. That's what makes the difference between a successful and not a failing experiment.
Doctors Woodley and Rosenfeld have developed a seeding technique known as dynamic seeding to stimulate the growth of cumulus clouds. Their research continues in Texas and Thailand. This method works in harmony with nature and could not succeed if it challenged the awesome power of the atmosphere.
Officials are reporting scattered cloud outages in Midlothian, while in Rico, police say at least one house has been reported struck by lightning. The National Weather
Here, the concept of cloud seeding is explained. Clouds form when moist air rises in an updraft and cools to condensation. Tiny, visible water drops form on minute dust and salt particles. As the moist air rises and cools further, these water drops grow larger. In many clouds, the drops fail to grow large enough to fall as rain. The challenge of cloud seeding is to produce raindrops large enough to fall before the cloud dissipates. The seeding technique used to enhance rainfall in West Texas deals with cold clouds, in which most of the drops in the updraft are not frozen, even though the cloud air temperature is below 32 degrees Fahrenheit or 0 degrees Celsius. These drops are supercooled. The seeding of cold clouds makes use of the principle that when water changes from liquid to ice, heat is released into the air. Clouds thrive on that heat. Seeding with small particles called ice nuclei, such as silver iodide, is done from an aircraft in the cloud updraft which contains supercooled water. These nuclei are produced by flares, which are released from the aircraft and incinerate before reaching the ground. There are no known impacts of cloud seeding on the environment. Seeding in the updraft freezes the water, creating ice particles which grow larger at the expense of the remaining water drops. This seeding-enhanced ice mass is supported by the heat-invigorated updraft. Eventually, this ice mass falls and melts as rain. When the increased rainfall reaches the ground, an outflow is produced. This generates regions of convergence where new clouds can grow. These might also be seeded. In clouds with large raindrops, the heat released as the drops freeze may be large enough for the cloud to support the increased ice mass and still grow to great heights. The results to date, which indicate increases in rainfall up to 100% for individual clouds, are not yet conclusive. Scientists feel the research must continue until the cloud seeding technique has been tested and proven. Most Texans understand the important part water plays in their lives, and while some are skeptical, many are supportive of attempts to augment their water supply through cloud seeding.
Well, of course, moisture is the determining factor of whether you make a success of it or not. You can have good cattle and you can have good land and everything, but if you don't get that rain, well, it's all for naught.
The only thing we're concerned about is ample rainfall.
We depend on the weather. If we have a good average rainfall, well, we have good crops, and then we have some awful short crops too.
In fact, that's our greatest horror, not getting rain.
We don't have a water well on the ranch, nor a windmill. It's all, I built surface ponds.
We have surface ponds, and all of our water is from runoff. But there isn't any subsurface water here on these ranches.
Oh yeah, it'd be a tremendous help. If we get a good rain now, we could have a pretty normal crop.
Well, we think cloud seeding has helped us in this area.
That's made a difference certainly in the amount of moisture that we've received on this ranch compared to the average annual rainfall before they started it.
Weather enhancement is invaluable to us. If we can get an extra half an inch or an inch of rain, we have water to drink and water for our grass.
Yeah, I'd say good luck to them. I hope they can do it. It'd be a big help if they could.
Well, my neighbors all think it's a good deal. I mean, they support it, and it benefits the people on downstream too.
Any extra rainfall that we're able to squeeze out of a cloud is real beneficial to us.
Each day of the project brings unique challenges. Weather conditions must be evaluated before any flight operations are scheduled. The early morning launch of a weather balloon by the National Weather Service in Midland monitors the atmosphere for data critical to that evaluation. Continuous surveillance for showers by the powerful new Doppler radar also helps project personnel assess weather conditions.
It's already impacted them in a big way, just letting our meteorologists be able to dissect storms and know what they have within them. With our old radar, we were able to see some things, but this opened up a whole new area for us to really know what a storm, what potential it has. In addition to that, I get rainfall estimates and much crisper view of the amounts of intensity of the rainfall versus the old radar as well.
A morning weather briefing is then conducted and a plan for the day is made. On this day, conditions are favorable for seeding and a go day is declared. Typically, project personnel have only 2 hours to ready the project radar for operation and prepare the aircraft for flight. Cloud seeding research requires a rugged, high-performance aircraft and state-of-the-art instrumentation. A laser imaging probe is used to measure and count tiny cloud particles, while other probes measure temperature, dew point, and vertical motions within clouds. Hot wire devices measure cloud liquid water content, and another laser imaging probe measures water drops and ice particles up to 1 millimeter in diameter. All of these instruments feed data to onboard computers, allowing real-time viewing of the measurements and post-flight analysis. The aircraft also carries a video camera mounted near the cockpit windshield for documentation of the flight. Silver iodide flares are carried in racks mounted on the belly of the aircraft. Each flare is activated electronically from the cockpit and produces trillions of microscopic ice nuclei. After checking and rechecking each system, the mission begins.
Temperature and DMT all on. All right, close to solid right here. Yeah, we're almost entering cloud base. Skywinder radar. This is Cheyenne 234 Kilo. Do you read over? Okay, ready. We're coming up through 16,000 feet. We're just south of the Big Spring VOR. Would you give me a quick echo update, over?
10-4 Bill, you got some sails out on the VOR way and out there.
Nice looking clouds out here.
That one off the wing there is quite nice.
Yeah, so one of these is going to go.
Now this one up here, look at the tower.
Yeah.
This one's coming off real
There's
nice.
a whole bunch of them. Whole bunch of bubbles coming up here.
Well, this tower's lasted a long time. This real big one.
Yeah.
Just sits there.
Just keep going.
Yeah, let's go to the one, the farthest over here. This tower right here looks awfully good. Right off the wing here.
Good.
Just take it over here. George, how about a decision?
Decision is do seed.
Seed, all right.
Okay, you've got one left on this this bunch.
Well, let's go to the next one then.
Okay, go to 3. Give yourself an advance. You're set. Good. Okay, you're over, clock.
Now 1, advance. 2, advance. 3, advance.
Rain.
4, advance.
Rain.
5, advance. 6, advance.
Rain.
7, advance. 8, advance.
Rain. Large rain.
9, advance. 10, advance. 11, advance.
You're flying
12,
into large
advance.
rain. 3 millimeter rain.
13, advance. 14, advance.
All right. That was a very good one.
That was the most rain I've seen in the cloud this year,
Yeah.
I think. We'll have to check the measurements.
As far as rain, yeah, I don't know. What was the water like?
Over 4 grams of cloud water.
Yes, it's both. Something. That's what we were looking for a very long time.
This one could be explosive, I can't tell yet. About 9 past 2. We'll get ground flow in this one, you better believe.
Yeah, it's frozen, all right?
Oh, that fast?
Yes.
My goodness. I hear ground flow, I hear ground flow.
Huge ground flow.
I hear ground flow, I hear... Whoa, I hear a lot.
But now it is a large raindrop. That was not frozen. Yeah, that was rain there in the middle. Now, ground flow, not clouds. Freezing raindrops. Freezing raindrops, very large ones.
Good updraft. Look at this updraft. Whoa.
Right. Oh.
This mission proved successful. Seeding has produced the predicted changes. More ice was produced, heat was released, and buoyancy was increased. The cloud was invigorated by the seeding, causing it to grow larger, last longer, and produce more rainfall. Cloud growth and precipitation continues as the aircraft returns to the airport. No one case can prove seeding effectiveness. However, the cumulative weight of the evidence indicates seeding does indeed increase rainfall. For the scientific crew, the workday does not end when the aircraft lands. Many more long hours are needed to process data and assess the mission. This grueling schedule will be repeated the following day. There are no shortcuts in scientific research. It has taken many years of dedication to learn if and how cloud seeding works to increase rainfall. More must be done. With support from government, business, farmers, ranchers, and from the people of West Texas, more will be done to develop proven cloud seeding technology to enhance the critical water resources of this region into the 21st century.